Alrighty, so this is Chapter 1, Section 2, or Lesson 2 for Math 8, and we are going to be talking about powers and exponents. So the first piece here, we have some fill-in-the-blank pieces. So it says, a blank is a way to write a product of repeated factors. So that's what we call a power. It's a way to write a product of repeated factors. The blank is the factor. The blank tells us how many times the base is used as a factor. So it actually kind of gives us the answer in the second one. So the base is used as a factor. So the base is the factor. And the exponent is how many times we use that base. So before we jump into this diagram, I'm going to back up just a second. And I want to go back to this repeated factors idea. So let's take a kind of big step back to when we were back in elementary school, and we were learning about multiplication. So we're going to take a step back, ignore this diagram just for a second, and I'm going to write this over on the side here. So if I have 2 plus 2 plus 2, don't know why the plus didn't show up there, like this. So we have this repeated addition. I'm adding the exact same thing over and over and over again. Well, there's an easy way to write this. We learned this back in elementary school. Instead of saying 2 plus 2 plus 2 plus 2, I can say 2 times 4. And the little dot means times. We can see that actually in the diagram here, but that's what this means. Either way, if I were to add these up, I would get 8 here, or I would get 8 here. It's the same thing. You're just writing it in a different way. So we learned that if we have repeated addition, we can write that as multiplication. And that helps us write it a little shorter instead of having to say all these 2's. Because what if we had 2 and we'd write it 100 times? Oh my goodness, that's going to get tedious. We don't want to have to do that. But we could do 2 times 100 and we would have the same answer. So it's just a quicker way to write that. This idea, when we go to power, is the same thing, but now instead of plus, 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 we're going to have times, times. So now we're multiplying. It's repeated multiplication instead of repeated addition. So now we're repeating multiplication. So let's go ahead and Let's go ahead and fill in our diagram here. So this arrow here points to the entire circle. So this is what we call a power. It's the whole thing. It's the base and the exponent put together. It's the whole thing. We call that a power. The base is always the larger number there. So this is our base. In this case, it's a 2. And then the exponent is always going to be that little number that's lifted up next to the base. So this is our exponent. All right. And what this tells us, remember, and I have this mistake, so I'm going to say this. Students make this mistake all the time where they say it's 2 times 3, and the answer is 6. This doesn't mean 2 times 3. The 3 tells us how many 2's we're using, or whatever the base is. So it just tells us how many 2's we're using. So I have 1, 2, 3 2's. So 2 times 2 times 2. It means 2 times itself 3 times, not 2 times 3. I know that sounds very similar. I'm using some of the same words, but it matters how I say it. 2 times itself 3 times. So again, the exponent just tells us how many of the base to use. And then we multiply 2 times 2. And if we did this, we go 2 times 2 is 4. 4 times 2 is 8. So you can kind of connect them like that if that helps you use them up. Or I've seen students go, 2 times 2. They're crossing them off so they know they've used it. And they get 4. And then they use times 2 again and 8. So you can cross them off however you need to do that in order to help you know that you already used that factor. So down here, this just shows us how to say it, what we see, the words, and then the factors that we would see. So we have 3, and we have a 1 exponent. So we'd say 3 to the first power. Anything to the first power is itself. Because remember, this 1 is telling me how many 3's I'm using. So if I'm only using 1 3, well, then I have 3. Now we have 3, and our exponent is 2. So remember, all of these are the same base in this example, just kind of, so they all have 3's, but the exponent is what's changing. So now we say 3 to the second power or 3 squared, because a 2 for an exponent has that special name of square. So we can say that. If you don't remember that, you can always just say to the power of, and whatever number it is that you're raising it to. It means the same thing. So now I have 2 3s. So 3 times 3. Here's my 2 3s. 3, and then we have an exponent of 3, so 3 to the third power, or you can say 3 to the power of 3. It doesn't necessarily matter how you say that one, because you can kind of swap the words just a little bit. Or 3 cubed, because that exponent of 3 also has a special name, which is cubed. And here I have my 3 3s, because remember, this tells me how many of the base I'm using. All right, now we have 3 and the exponent of 4. So you'd say 3 to the 4th power, or 3 to the 4th. 3 to the power of 4 is also another way you could say that. So we're just identifying that we're lifting it to the power of 4. So here are my 4 3s. And then they give you these little dots. This is showing like we're kind of skipping down. And they have 3 and an exponent of n. And we say 3 to the nth power, or 3 to the nth, 3 to the power of n. Again, you can say it that way too. What this means is that we can plug any number we would like in here as long as we follow this pattern. So n factors, it would just depend on what I plugged in here. If I had 3 and instead of n, I could choose 10. I would have 10 3s. Or I could have 100, and I would have 100 3s. So what all this is a placeholder, this n, it's a variable, and it's just saying that we can choose any number we would like for that exponent. And as long as we're following this rule, where we write down the number of factors and we multiply, we'll still get the correct answer. All right, let's go ahead and scooch down here and look at some of the problems. So we have 2 problems down here. This one actually has a couple, but we'll get to that in a minute. So Interstate 70 stretches almost 2 cubed, or to the third power, times 5 squared, or to the second power, times 11 miles across the United States. About how many miles long is Interstate 70? So if I'm looking at this, and I go 2 to the third, 2 to the 5th, 5 squared, I said that backwards, and times 11. So remember, repeated multiplication. This means I'm using 3 2s. So I have 2 times 2 times 2. I have another multiplication sign. I'm going to make that one a little bigger so we can kind of see it's the one that was already there. This means I have 2 5s. That's what 5 squared means. And then I'm using that little bigger multiplication sign. They're all multiplication signs. I'm just indicating the bigger ones were already in the problem there. Times 11. So now we have all of this stuff to multiply. So we'd have 2 times 2, and we get 4. Times 2 again, we get 8, which is actually that example up there. We already knew that was 8. So I'm going to go ahead and write 8 times 5, we'd get 25 times 11. So I just reduced really quick these exponents. So I have a little less numbers here. So now we want to go 8 times 25 times 11. So if we think of quarters in this, whenever I see 25s, I always think of quarters, as in money. So if I have 8 quarters, it means I have $2, right? Well, in this case, we're not looking at decimal places, so it means 200 times 11. And that was just kind of a bit of mental math. For whatever reason, I always relate it to money if I can, because it makes it a little easier. But you are also welcome to do it this way. And you can go 8 times 25 times, and then we would do 11. And so here's our end answer. Where'd my screen go? So when I multiply that, we can see that it's going to be 2,200. 2,200. All right. So we just keep multiplying each of the numbers. So let's go ahead and look at number 16 down here. And these are numbered from the book, so they were kind of examples taken from the book. That's why they have pre-numbers. It's not 1 and 2, it's 8 and 16. Okay, so this is reason abstractly. So they want us to kind of think ahead on this one. Simplify the expression below to develop a rule for multiplying powers with the same base. So they want us to think about what we know right now and come up with a rule. So we have 2 to the second power, 2 to the third power, or 2 squared and 2 cubed, equals 32. So how could we write that differently? So I'm going to go ahead and expand these, and what that means is I'm going to write out all the factors. And remember, there was a big multiplication sign, so I have 2 squared, which means 2 2s, Now I have 2 cubed, which means 3 2's. So if I'm looking at this, how many 2's do I have? 1, 2, 3, 4, 5. It's all multiplication. So if I can say 2 squared here instead of 2 times 2, and I can say 2 cubed here instead of 2 times 2 times 2, why can't I say 2 to the 5th power if this is just another multiplication sign? And the answer is, you can. That's exactly what we want to say. So if we look at this next one, we have 1 3 times, and now we have 2 3's. 3 times 3. So again, I can combine them. There's no reason I can't. It's all multiplication. It's all the same. So now I have 1, 2, 3 3's. And the same thing here. So I have 4, and there are 3 of them, because it's to the 3rd power cubed. And then I have another one here. So just multiplying by 4. So now I have 4 4's. So I can combine those exponents. So hopefully we're kind of seeing a pattern here. What we're doing is we're adding. I have the exponent of 2, I have the exponent of 3. I can add those together to get 5. And then here I have the exponent of 1. So I only have 1, 3, and I have an exponent of 2. If I add those together, I get 3. And here I have an exponent of 3, exponent of 1. If I add those together, I get 4. So if we think about this without expanding it, I have 2, I have 3. If I add those exponents together, I get 5. I can expand it if I want to see them all and I want to count them. That's perfectly fine. But this is also another way. So if we have the same base, and this is a big one, I haven't said this out loud yet, but if we have the same base, that's a B, then we can add the exponents. So now that I have that written down, I'm going to explain what I mean. So the same base, remember, I have 2 and 2. I'm adding the exponents. This one I have 3 and 3, and I'm adding the exponents, and again, there's 1 there. We just don't write the 1. We don't really need it. We know there's only 1. Here I have a base of 4 and 4, and I can add the exponents, x and x, and I can add the exponents. So just make sure it can't be completely, you can't have 2 squared, whoops, writing that funny, times 3 to the 4th power and say, okay, I'm going to add the exponents here, and I'm going to have an exponent of 6. Well, which base does that go to? It doesn't go to either one because you only have 2 2's and you only have 4 3's. So you don't have 6 of either. You have 2 of this one and 3 of this one. So be careful about that. They have to be the same base. So it can't be 2 different numbers. It has to be the same thing. 2 and 2, 3 and 3, 4 and 4, x and x. Whatever the number is. It could be 100 and 100. Doesn't matter what the number is as long as the base is the same. All right, so that was section 2, and I will see you in section 3.